Welcome to the second lesson of Unit 4. We are going to be solving quadratic equations graphically. So recall from Unit 3, we solve quadratic equations using three different methods, either by factoring or completing the square or by using the quadratic formula. Today we're going to solve the equation graphically. Okay, so we are going to take what we learned from first unit, graphing quadratic functions, and we're going to combine that with quadratic equations and then solve quadratic equations. Okay, so before we actually start solving equations, what I would like you to do is to get all the properties of this particular quadratic function and graph it. Okay, so go ahead, give it a try. Okay, so this is what I got. Hopefully you got something similar for the table of values. These should be the same. This could be different, but I mean, it should be somewhat similar. I mean, to get all these information, you really need this table value, right? So one thing you notice, I put -4, 6 in red, and that is because I started with my -3, okay, and goes towards the positive x values. I notice when x becomes 1, or when x is 1, y value gets really big. So really, there's no point to put a 2 here for the x, because it's just going to be super big. That's going to be outside of the grid. Notice I didn't even put 1, 16 on the grid, because I can't. Okay, so I went back to get -4 and 6, and again, because I know this pair of coordinates, I don't even actually need to calculate. I can use the fact that quadratic functions is symmetrical, right? The graph of the quadratic function is symmetrical. So once I see this is my vertex right here, I see these two are the same. That means these two will be the same as well. And so that will be 6. This should be 6. The x value will be, well, 1 less than -3, which is -4. And that's why I have this pair of points, or this pair of coordinates. Okay, so there's my graph. Okay, so that's what we did last time. Okay, we are going to take this and then going to take one step further, and we're going to solve the quadratic equation right here, and we are going to graph its corresponding function. Okay, so I think you might have guessed it. The corresponding function would be f of x is equal to x squared minus x minus 6. This is the corresponding function. Okay, now once we have this, we can then make table values. Okay, so let's see. I am going to use same thing, I guess. -3, -2, -1, 0, 1, 2. I don't even know if that's enough. You know, I'm just gonna plug it in and check. That'll be 9. Okay, I'm gonna do it right here actually, just so I have more room. -3, -2. I'm just gonna stop right there for now. Okay, just gonna try it and see what happens. -3 squared minus -3 minus 6. This is 6. If I plug in -2, I would get 4 plus 2, which is 0. Okay. If I plug in -1, I would get 1, 2, so that's -4. Okay, so it's getting smaller and smaller. If I plug in 0, I will get -6. That one's easy. If I plug in +1, I will get -4. Am I right? 1 minus 1, 1 minus 1, no, -6. Almost made a mistake there. Okay, 2. Okay, I think I can stop right here. Okay, I don't need to plug in. 2 is going to be -4. And how do I know that? Okay, because these two are the same. Okay, that means the vertex is going to be right in between these two x values. So the vertex is going to be at 0.5. I don't know what the y value is. I don't really care. But I do know, because again, it's symmetrical, right? The parabola is symmetrical. So if these two are the same, these two will be the same, and these two will be the same. So if I go one more, it's going to be 3, 0 for sure. And if I go once again, if I go one extra x value, it will be 4, and the y value will be 6. But I think that's all I need, because I get my zeros, right? We want the equation equal to 0. We got what we wanted. Okay, we got what we wanted. So how do you know we only have 2? Well, you'll graph it and you'll see we can only have 2. We can't really have anything more than 2 values that's equal to 0. Okay, so let's see. Let's graph this. -3, 6. Again, this black dot right here in the middle is the origin. So 1, 2, 3, 1, 2, 3, 4, 5, 6. Here's my first x coordinate, -2, 0, -1, 1, 2, 3, 4, 0, -6, 1, -6. Okay, so again, the vertex is going to be somewhere here. I don't know where it's going to be exactly, but it's not a point. We don't really care. 2, -4, 3, 0, 4, it's going to be at 6, like that. Okay, so here is our graph. It's going to go and then come back up. Oh, I missed it. Oh, I missed it badly. Okay, I'm going to make the dot bigger. There you go. Ah, so bad. Okay. A little bit better. Okay, so you can see these two will be the solutions, right? It'll be at x equals -2 and x equals +3. Again, like I said, because we want equal to 0, we got what we wanted right here. And when did that occur? It occurred at when x equals to -2 and when x equals to +3. Okay, so I will ask you to try part B yourself and see how you do it. Okay, how you go, how it goes. Good luck. Alright, so here is my table of values for part B. Notice how I went from -3 straight to -1 and I just skipped -2. That is because the y value here is so big already. I don't think by dropping 1 from the x is going to change that much for y, so I just skipped -2 for the x and went straight to -1. You can see I stopped at +3. I didn't continue with I didn't continue with +4 because I see these two are the same already. Okay, so that means it's going to bounce back up now. Okay, so I mean you could continue, you just get a 4, right? It's just going to get bigger and bigger. Again, that's not what we wanted. We want this number right here, 0. Okay. So what does that mean actually? This right here, these are the same. That means right in between those two y values or those two x values is the vertex. So this is actually the vertex right here. Okay. So if I plot these points, I'm gonna go -1 and 9, 0, 4, 1, 2, 3, 4, 1, 1. 2, 0, and then 3, 1. Here we go. Oh, not right there. 3, 1, 4, 4, 4. I know it's going to be 5, 9. Okay, again, it's symmetrical, right? So here is the graph. Notice how we only have one single x-intercept. Okay, that is our only x-intercept. And therefore, that is the only solution. We only have one solution, x equals to 2. Okay, x equals to 2. Okay, so notice how in the first example, part A, we had two x-intercepts, we have two solutions, right? Here we have one single x-intercept, we have one single solution. Makes sense because again, that's where equal to 0, right? And x-intercept means when y equal to 0. That's exactly what we wanted to see. Okay, so I believe there's a third example. I think you probably can guess what's coming, but you know what? Give it a try. Again, put it into a table of values and see what you get. All right, so it's a plus sign there. Once you put into a table of values, okay, this is what you get. Notice how I went straight from -3 to 0 again because that's 55. That's way too positive for me because we're really looking for 0, right? So I jump all the way to 0. Notice how I actually never got into the negative portion, right? So let's see what happens. I'm going to start with 0, 6, 1, 2, 3, 4, 5, 6, and then 1, 2, 2, 4, 3, 12. That's again out of range, but I'll put it right here, somewhere here. Okay, so we don't actually have any of the repeating y values. However, we notice this is decreasing, but from here to here, this actually increased, right? This is decreasing, this is -4, but from here to here, this is actually a +2. So that means when we draw the parabola, this is already going up. So that means the vertex is somewhere between 1 and 2. Okay, it's not going to be halfway. Okay, it's somewhere between, because these two y values are not the same. So that means our parabola looks something like this. Oops. Looks something like that, right? Yeah, we don't have any x-intercept, right? We just don't have any x-intercept. Okay, so I mean, how can we guarantee that it actually, because I mean, this is still possible, right? This is still possible. Something like that is still possible. Now, how do I know it doesn't go through? Well, from the table of values, you don't, okay? And I mean, I do know that it's not gonna go through like that, so I'm just showing you it will look like this, okay? But how do I know that it's not gonna go through the x-axis? Well, this really brings back what we learned in Unit 3. How do we know how many x-intercept is gonna have? Recall that is related to how many roots we're going to have for the quadratic function or quadratic equation, right? So what we need to do is really looking for the discriminant, right? What is the discriminant here? Well, discriminant, recall, is b squared minus 4ac. So this is -7 squared minus 4 times a times c. This is 49 minus 72. Well, this is -23. And recall, if this is less than 0, therefore no real roots. And if there's no real roots, that means there's no x-intercept. And therefore there's no solution right here. And there's no solution. Okay, so really, when we solve quadratic equations by graphing, we are just looking for the x-intercepts. So we can tell quite easily how many solutions we're going to have based on the discriminant. Okay, so here's the table, right? Here's the function. These three are the ones we worked on. Okay, so here is the first function right here. Right, here's the corresponding function. Okay, the x-intercepts, well, we had our x-intercepts. They were -2 and 3. -2, 0, and 3, 0. The corresponding equation is x squared minus x minus 6 equal to 0. What was the discriminant? Well, I don't know actually. Let's calculate. It's b squared, so -1 squared minus 4 times a times c. This is +25, I think. Yes, again, this is bigger than 0. Guess what? 2 solutions. For the second function or second equation that we solved, x squared minus 4x plus 4 equal to 0, the x-intercept, or just one of them actually, the x-intercept was 2, 0. What was the discriminant? You can probably guess it. It's going to have to be 0. But you know what? Let's just check. b squared minus 4 times a times c. This is 16 minus 16. Definitely 0. Equal to 0. One solution. Makes sense. Because when the discriminant is 0, recall it was one single real root. Therefore, one solution. Finally, the third example, it was, well, we don't have any x-intercept. So none. The corresponding equation was 3x squared minus 7x plus 6. We just showed that b squared minus 4ac, this was -23, which is less than 0. Makes sense. When the discriminant is less than 0, there's no real root. Therefore, there's no x-intercepts. Therefore, there's no solution. Okay, so that's basically it. Okay, solving quadratic equation by graphing, basically you just graph the quadratic function and look for the x-intercept. Okay, and you can quickly tell how many solutions there are by looking at its discriminant. So basically I answered these 3 questions already, but you know what, let's just read it over again. How are the graphs of quadratic function, the 0 of the function, and the roots of its corresponding quadratic equation related? Well, they are exactly the same thing, right? The zeros of the function is the same as the roots of its corresponding equation. Okay. How can you use the graph of a quadratic function to determine the root of its corresponding quadratic equation? Well, then you look for the x-intercept. Look for x-intercept. Again, like I said, I think I mentioned all these already, but I guess let's just put it in words. How can you use discriminant to determine the number of roots? Well, if b squared minus 4ac is bigger than 0, then 2. If b squared minus 4ac is equal to 0, then 1. If b squared minus 4ac is less than 0, then 0. Right? Then none of them. We don't have any roots. You don't have any zeros. You don't have any x-intercepts. Okay. So there you go. Predict the number of roots for this, or yeah, and then verify your answer graphically. Okay, so good luck. Give it a try. Okay, so here's the table of values that I came up with. Okay, so first of all, when you do the discriminant, it equals to -23, so there should be no real root. Here is the table of values that I came up with. Again, I can see these three are decreasing. However, from 0 and onwards, the y values are increasing. Therefore, our vertex is somewhere between 0 and 1. And again, we can't really tell if we don't do the discriminant, but we already know that, you know, discriminant is -23, there's no real root. So if you graph this, your graph should look something like this. -1, 1, 2, 3, 4, 5, 6. 0, 3, 1, 2, 3, 1, 4, 2, 9. So again, it will probably look something like this. Okay, and you can see clearly, because here's the x-axis, there's no x-intercept, there's no solution. Okay, that's it for this lesson. Hopefully that makes sense to you. It really is just combining the last lesson and the lesson from Unit 3 combined together to have this lesson, right? It's just putting different concepts together. Okay, so you can use the discriminant to tell if there's a solution or not in your quadratic equation. We mentioned that in Unit 3. And you can turn that into a graph because the number of solutions really depends on how many x-intercepts you have in that quadratic function, the graph of that quadratic function. So for the last example here, you can see there's no real root, therefore there's no x-intercept, therefore there is no solution. Okay, no solution. Okay, that's it. Good luck. Do some practice questions. Let me know if you need help.